Alright, we are back and we just finished going through building interactive websites. And now where we learned how to incorporate JavaScript into HTML, and now we're looking into what is the DOM. Alright.
Hey guys, I'm Matt, a developer from Ohio. In this video, we're going to ask and answer, what is the DOM? If you've done any web development, you probably at least heard the term. We're going to explain what the DOM actually is, learn what it looks like, figure out how to use it, and most importantly, why you should care about the DOM at all. So, what is it? Well, most of the information we need is right in the name. DOM is an acronym, which stands for Document, Object, Model. In a broad sense, the Document Object Model is the browser's internal representation of a web page. Every page relies on a DOM to spell out exactly what stuff should be on the page, and how that stuff relates to all the other stuff. To understand more about what the DOM is, let's take a look at each part individually. You may have heard web pages referred to simply as documents. The word document really just refers to any way of structuring information, articles, books, scientific papers, whatever. But from a web development point of view, document is another word for web page, so the DOM is a model of all the stuff on a web page, or document. The stuff on a web page is objects, or at least that's what the DOM calls them. You may have also heard the term nodes or elements used to describe the stuff on a web page. These are types of objects, but what are these objects exactly? Well, the most obvious kind of stuff on a web page is the content. Every page has words. Content also includes images, videos, buttons, etc. All of those things are considered objects. You may have also heard this stuff referred to as elements, which is a specific kind of object. Another kind of stuff is structural elements, which are things like divs, containers, and sections. You may or may not be able to actually see all the structural objects on a web page, but they're needed to organize the content. The remaining stuff is mostly attributes. Every element has attributes. For example, HTML elements can have classes, styles, sizes, etc. All of these attributes are objects in the document object model, but they aren't elements like content or structure. The M in DOM is model. A model is a representation of something, and it helps us understand how that something is put together. There are models for anything you can think of, because complex things need some way to be universally understood, analyzed, and used. I'm sure you've seen blueprints, floor plans, IKEA directions, recipes. These kinds of models are instructions. They depict the objects in enough detail that someone can recreate the objects. Another kind of model is more like a summary of big ideas or complex systems. You can't build a galaxy, so you don't need instructions per se, but you can understand it with the help of models. So then, what kinds of models do we have as web developers? We have the DOM, which is a model of web pages. We'll see soon how it acts as a set of instructions for the browser to follow, and as a summary of web pages for us to read. So what is the DOM? It's a way to model the objects in a document. Or, in simpler terms, the DOM represents the elements and attributes on a web page. Now that we know what it is, let's take a look at what it looks like. The DOM is a kind of data structure called a tree. All that means is that every object is hierarchically under another object. An object can have multiple children, but only one parent. When we talk about parents and children, we're referring to the relationships between objects. Child objects are under or within parent objects. You might even say that a parent object sort of owns its list of children. If we were to remove any object from this tree, all of its children, and their children's children, would all be removed as well. A tree graph can be used to represent all sorts of models. For example, we can try to represent a galaxy, like I mentioned earlier. The top object, the parent of all parents, will be our galaxy itself. This position in the tree is known as the root node. The children of the Milky Way are its stars. There are obviously way more than two of these in our galaxy, but our model doesn't have to cover absolutely everything. Our star is called Sol, which is why we refer to our system as the solar system. The children of the solar system are its planets and other space stuff that orbits around the sun. Again, I'm not showing every orbital body here. It's important to realize that the children of an object don't have to be the same type of stuff. Here, we have 2 planets and an asteroid belt. Under Earth are planetary sections, like continents and oceans. We could go down and down this tree until we're talking about particles, but I think you get the idea by now. So, let's take this model of a galaxy and turn it into a model of a website. A website, or document, is structured in the same way as a galaxy. If you've written any HTML, you know that the HTML tag is at the top of the file, then head and body. In this example, we have a pretty standard website with a header, main section, and footer. In the header, there's a logo, a heading, and a navigation section. And let's not forget that attributes are objects too. The image is going to need a source attribute to reference a PNG or something. Every one of these things is an object, and every object has exactly one parent. This is the DOM. Or at least, it's one way of visualizing the DOM. So what does the DOM look like in real life? I mean, you won't see a tree like this in your code or in a browser. In my opinion, the best way to visualize a real website's DOM is to open up the developer tools in your browser. This is an image from Chrome's Inspect Element feature. This list of tags may not look like a tree structure at first glance, but it's the exact same information as our graph. Every indentation level in the inspector is a vertical level from the graph. The buttons to the left of some tags hide even more children than we can see here. So, we still see that source is an attribute of image, which is a child of header, which is a child of body, which is a child of HTML. This is probably the most common way to visualize a DOM, because it looks just like HTML. Most web developers can read HTML, so it's helpful to see the document in a familiar format. Plus, because it's built into the browser, it's super easy to access. So, is the DOM HTML? This is a common misconception, because the most common way of viewing the DOM looks like HTML. But there are more ways to create a document than just HTML. Lots of technologies can be used. You can use PHP to generate HTML when the page is loaded. or you could use JavaScript to edit DOM elements on the fly. You could even use technologies like React or Angular to generate entire pages without writing any HTML. So the DOM isn't HTML. The DOM can be represented by HTML, just like it can be represented by the tree graph. These are formats that the DOM can be viewed in, but the DOM itself is the underlying data structure of objects that make up the document. Let's take a look at some ways to view the DOM. As we've seen, we can represent the DOM with this tree graph. This is the best way to graphically represent the DOM's actual data structure, but it's not very helpful when trying to write code. It can also be represented in the browser's developer tools, which I mentioned is probably the most common way. The Inspect Element tool allows us to see the document in a way that more closely resembles a web developer's understanding of web pages, in that it reads like HTML. Source code is another representation of the same document. We could figure out how a web page will look by reading the entire source, but tools like Inspect Element were created specifically so we wouldn't have to. The source code is, however, the only way of viewing the document that allows us to edit the document. It's a lot like how a musician can know what a song sounds like from its sheet music, or how an architect might know what a building looks like from its floor plan. These are all representations of a specific thing. And just like how we can know what a web page will look like based on the tree graph, developer tools, source code, the browser also knows what it'll look like. The rendered web page is another representation of the same document. We can edit the DOM via source code. A browser reads the DOM in order to render the web page. Because we can control the DOM with our source code, we can control the rendered web page. If you recall, I said earlier that a model can be either a set of instructions or a description. For a browser, the DOM is a set of instructions on how to build a specific web page. For a developer, the DOM is a readable description of those instructions. So, how is that visualization useful to you as a developer? Now that you know how to visualize and understand the DOM, you can more easily control the instructions sent to a browser. No matter what language, library, or framework you're using, if you're changing something on a web page, you are using the DOM. Hey, thanks for watching. You can join the conversation by subscribing to this channel or dropping a comment below. And if you want to take your skills to the next level, you can start learning on Codecademy today.
I could subscribe.
Wow, we're crunching tons of polygons here.
What's going on? Where's Regina?
Hi, I'm LaDonna. I invested in Invesco QQQ.
Okay. Next is the next lesson. Okay, so this is something I also went through, but let's go through this together. So the document object model is a powerful tree-like structure that allows programmers to conceptualize hierarchy and access the elements on a web page. DOM is one of the better named acronyms in the field of web development. So it's just a way of conceptualizing the hierarchy of all of the things that we are building, all the elements we're building together. In fact, a useful way to understand what DOM does is by breaking down the acronym, but out of order. DOM is a logical tree-like model that organizes a web page's HTML document as an object. There are other types of documents such as XML and SVG that are also modeled as DOM structures. The DOM is a language-agnostic structure implemented by browsers to allow for web scripting languages like JavaScript to access, modify, and update the structure of an HTML web page in an organized way. For this reason, we like to think of the DOM as a link between an HTML web page and scripting languages. The diagram to the right illustrates how an HTML document is modeled as a tree-like structure accessed by scripting languages like JavaScript. Let's look at the cheat sheet here. Ooh. There's parent-child relationship. Okay. So I really like this picture here. HTML file is on the left. Yeah, and DOM is a link between the two, as they said. The scripting languages on the right. And they said it could be anything. It doesn't have to be JavaScript. It could be PHP, and I think they said React. So the DOM structures HTML page as a tree, and the script uses this model to update page. DOM, document object model. So the script kind of uses these DOM to access these elements. To access, modify, and update the structure of an HTML web page in an organized way. It is a language agnostic structure implemented by browsers to allow for web scripting languages like JavaScript to access, modify, update the structure. The DOM is a logical tree-like model that organizes the web page's HTML documents as objects. The DOM as a tree structure. Tree-like modeling is used in many fields, including evolutionary science and data analytics. Perhaps you're already familiar with the concepts of family trees. These charts represent the familial relationships amongst the descendants of a given family name. The DOM tree follows similar logic to that of a family tree. A family tree is made up of family members and their relationships to the family name. In computer science, we could call each other family member a node. We define a node as an intersecting point in a tree that contains data. In the DOM tree, the topmost node is called the root node, and it represents the HTML document. The descendants of the root node are the HTML tags in the document, starting with the HTML tag, followed by the head and body tags, and so on. An intersecting point in a tree? The topmost node is called a root. So this would be a root. It represents the HTML document. So this is the root tag in the document, starting with the HTML tag, followed by the head and body tags. Okay, so each one of these is a node. The diagram of the right models the HTML document and labels the root element, which is the document. Observe the differences in the rectangular boxes and the curved boxes. These denote the difference in the types of nodes in the DOM structure. Parent-child relationships in the DOM. Following the metaphor of a family tree, let's define some key terminology in the DOM hierarchy. A parent node is the closest connected node to another node in the direction towards the root. Right. The child node is the closest connected node to another node in the direction away from the root. So this is towards the root, and towards the bottom is away from the root, which they call leaf nodes in a tree. This is almost just like a family tree, where the upper it is, the more grand the parent is. And knowing these terms will allow you to understand and discuss the DOM as a tree-like structure. In fact, you will also see this terminology used when referring to the nesting structure of HTML code. Programmers refer to elements nested inside other elements as the children elements and parent elements respectively. Add the appropriate HTML elements to the index.html file so that it reflects the tree diagram on the far right. Start by adding the title element. Make sure to nest the tags correctly so that the nodes follow the illustrated parent-child relationships. Add the div element to index.html so that it reflects the DOM diagram to the right. It reflects the DOM diagram to the right. Start by adding the title element. Make sure to nest the tags correctly so that the nodes follow the illustrated parent-child relationship. Okay, so the title is the child of the head, so that's why we put it inside of the head, and then for the div, add a div element to the index.html. Here the div is a child of the body and is a sibling of h1, so we put it on the same level as h1 inside of the body. Nodes and elements in the DOM. As mentioned, a node is the equivalent of each family member in a family tree. A node is an intersecting point in a tree that also contains data. There are 9 different types of node objects in the DOM tree. There are 9 different types of node objects in the DOM tree. In our diagram, the node objects with the sharp edge rectangles are of the type element, while the rounded edges rectangles are of type text. The rounded are text. The sharp edges are elements. Because they represent the text inside the HTML paragraph elements. Right, so the words inside of the element are also considered as a child of this HTML element. When trying to modify a web page, the script will mostly interact with I think someone says it's too small. Let me make it bigger. Okay, so elements are the building units of HTML pages. The script will mostly interact with the DOM nodes of type element. Elements are the building units of HTML web pages. They contain everything between an opening tag and a closing tag. If the tag is a self-closing tag, then that is the element itself. In the diagram to the right, the DOM nodes of type element are highlighted red. These correspond to elements in the HTML document. Move on to the next exercise when you're ready. Elements are the building units of HTML web pages. Attributes of element node. DOM element nodes model elements in an HTML document. DOM element nodes model elements in an HTML document. Much like an element in an HTML page, the DOM allows us to access a node's attributes, such as its class ID and inline style. In the diagram to the right, we have highlighted the paragraph element with an ID of bio in the HTML document. If we were accessing that element node in our script, the DOM would allow us to tweak each of those attributes or simply access them to check their value in the code. After studying the diagram on the right, feel free to click onto the next exercise. Let's see what there is to know in the cheat sheet. Now this is the same thing as before. So in here, they're showing the attribute is considered as some kind of child. DOM allows scripts to access the many attributes of HTML elements. Can you see that? Let me make it bigger. Oh, whoa, it doesn't. Whoa, whoa, whoa. Whoa, whoa. Okay, anyways, this thing says that the DOM allows scripts to access the many attributes of HTML elements. So this is a P element, and you can see that it has the attributes of ID and style. So as a review, the DOM is a structural model of a web page that allows for scripting languages to access that page. The system of organization in the DOM mimics the nesting structure of an HTML document. Elements nested within another are referred to as the children of that element. The element they are nested within is called the parent element of those elements. The DOM also allows access to regular attributes of an HTML element such as its style, ID, etc. With this understanding, you can begin to leverage the power of scripting languages to create, update, and maintain web pages. Alright, so what's the next lesson? Looks like I also went through this section as well, but let's go through it. Or the JavaScript and the DOM. Okay. Did we go through this already? Did we go through this? No, we did not. Oh, yes, we did not go through this. So, we know that it's a powerful tree-like structure, organizes the elements on a web page, allows scripting languages to access them. And this lesson will focus on some of the most useful methods and properties of the DOM interface in JavaScript. This interface is implemented by every modern browser. What is the DOM interface? Oh, it's considered as an interface. First things first. The document object in JavaScript is the door to the DOM structure. The document allows you to access the root node of the DOM tree. Before you can access a specific element in the page, first you must access the document structure itself. The document allows scripts to access children of the DOM as properties. For example, if you wanted to access the body element in your script, you could access it as a property of the document by typing document.body. This property will return the body element of that DOM. Similarly, you could access the title element with the .title property. See a comprehensive list of all the document properties. Comprehensive list of all of the properties. Inherits from the node and event target interfaces. So the diagram to the right illustrates that the document keyword points to the root node of the DOM. The document.body and the document.head properties act as though you were directly accessing HTML DOM element. Click Next when you're ready. To tweak an element. When using the DOM in your script to access an HTML element, you also have access to all of that element's properties. This includes the ability to modify the contents of the element as well as its attributes and properties that can range from modifying the text inside a P element to assigning a new background color to a div. You can access and set the contents of an element with the .innerHTML property. For example, the following code reassigns the inner HTML of the body element to the text "the cat loves the dog." The .innerHTML property can also add any valid HTML, including properly formatted elements. The following example assigns an H2 element as a child inside the body element. Use the .innerHTML property to modify the content of the body to display the text. This is the text of the body element. Notice that the previous content inside of body has been replaced. Yep, so we call the document object the body because we want to access the body. And then the inner HTML is this string. So we change that to add it in there. Okay, so let's restart this and see what it looked like before. Okay, so it actually did replace everything. Oh my goodness, it resetted everything. Oh no, now I have to do it again. Select and modify elements. In the previous exercise, we accessed the web page elements with the document keyword. What if we wanted to select a specific element? The DOM interface allows us to access a specific element with CSS selectors. Will allow us to access a specific element with CSS selectors. CSS selectors define the elements to define which a set of CSS rules apply. But we can also use these same selectors to access DOM elements with our script. Selectors can include the name of the tag, a class, or an ID. The .query selector method allows us to specify a CSS selector and then returns the first element that matches the selector. The following code will return the first paragraph in the document. You can also use other CSS selectors such as an elements.class or its pound ID or its pound ID. Well, it specifies a CSS selector and then returns the first element that matches that selector. The first element, keyword first element. The following code will return the first paragraph in the document. Another option, if you want to access elements directly by their ID, you can use the aptly named getElementById method. The example chains so that it selects the element with an ID of bio and sets its inner HTML to the text, the description. Call the .query selector method to select the tag h1 from the DOM. Access the element's inner HTML property to change the h1 title to Most Popular TV Shows in 2016. Oh, it didn't reset my work. So we did do that. Use the .getElementById method to access the fourth element with an ID of fourth. The ID of fourth, getElementById, the one with the ID of fourth, and replace the inner HTML with the content fourth element. getElementById and query selector. Query selector, so to select it by the CSS selectors. And to getElementById by the ID. Alright. Style an element. Another way to modify an element is by changing its CSS style. The style property of a DOM element provides access to the inline style of that HTML tag. The syntax follows an element.style.property format with the property representing a CSS property. For example, the following code selects the first element with a class of blue and assigns a blue as the background color. Whoa. Oh, wait a minute. Did we use query selector before too? Oh, we did use, so we can use query selector on the element type and by the class name. No. This is also an element type. Oh no, here I see they're using the class. So you can use query selector on both the element type and the class. Another way to modify an element is by changing its CSS style, the .style property of a DOM element provides access to the inline style of that HTML tag. The syntax follows as the following: element, .style, .property. Format, with the property representing a CSS property. Okay, so this property here they use is the background color. And then they assign it as the value. Unlike CSS, a DOM style property does not implement a hyphen such as background color, but rather camel case notation background color. Check out the MDN reference page to see a list of how CSS properties are converted into JavaScript. The following chaining syntax would also work. Style the background color of the body in the blog post document to match the color of the Codecademy text editor by using the .style property. Then it will assign the element of a blue background color. So they use a style property on the DOM element. They picked up a DOM element, they called the style property, and then they chose a specific property that they wanted to change, and then they set it. Select the background color of the body in the blog post to match the color of the Codecademy text editor. Then it will assign the element a blue background color. Create and insert elements. Just as the DOM allows scripts to modify existing elements, it also allows for the creation of new ones. The .createElement tag name method creates a new element based on the specified tag name passed into it as an argument. However, it does not append it to the document. It creates an empty element with no inner HTML. In order to create an element and add it to the web page, you must assign it to be the child of an element that already exists on the DOM. We call this process appending. The append child method will add a child element as the last child node. So we recreate an element, but it exists on its own, so we have to append it somewhere, to some child. The following code creates a new paragraph element, gives it an ID, adds text to the new elements .inner HTML, and appends it to the body of the document. Okay, they created an element, they gave it an ID, gives it an ID of info, okay, and then they set the inner HTML, and then so this creates a whole element, and then they attached it by using append child to the body. Unlike the .innerHTML property, the append child method does not replace the content inside of the parent. In this case, body. Rather, it appends the element as the last child of that parent. Okay, so in one of the previous exercises, we used .innerHTML to change the value inside, and it replaced everything. But if we wanted to keep it and just add on to it, we used the append child method. So here we wanted to create a new li, so we did that. And instead of changing it directly, we saved it into a variable and gave it an ID, and then we assigned the element of the text, and then and that created our element. And then we want to append it as a child to a parent, and we are appending it to some element that has an ID of more destinations. And in order to append it, we need to first get that from the DOM, and then we can append it. Alright, so to remove an element, in addition to modifying or creating an element from scratch, the DOM also allows for the removal of an element. The remove child method removes a specified child from a parent. Because the query selector method returns the first paragraph, the following code would remove the first paragraph in the document. It's possible to also specify a different parent with the .query selector method as long as you remove an element nested within that parent element. If you want to hide an element because it does not need to be loaded initially, the hidden property allows you to hide it by assigning it as true or false. The code above did not remove the element from the DOM, but rather hid it. This is not the same as setting the CSS visibility property to hidden. For a list of the best use cases of this property, read a list in the MDN documentation. So appropriate use cases is when it's relevant but maybe needed later, previously needed but not any longer. An off-screen canvas as a drawing buffer, reused by other parts of the page in template-like fashion. This is not what we want to use when hiding panels in a tab dialog box, when hiding content in one representation, while intending it to be visible in others. nested within that parent. Because it does not need to be loaded initially. Anyways, the point of this section is to remove a child, and so we can select an element with the ID oaxa. We did that, and save it to variable. Save it to a variable. Yes, we did that. Yeah, getting a specific. Where's oaxa? Oaxa. Something with an ID of oaxa. Okay, here it is. It doesn't show up. Select as parent, assign an ID of more destination. So we picked out a child, we picked out a parent, and then we want to remove this child from that parent. And because we want to remove a child, we need to be able to access the parent. So that's why we need to get both of these elements. So in the hint they gave us, they grabbed something, and then they just removed it from the body. I wonder if that could also work. Oh great. I didn't save it. Oh no. Oh no. Oh no. So we want to grab something with an element ID of oaxa. Destinations. Then we can let the parent dot wait, what I wanted to test was whether this one could work, if we can just call any random parent, or does it have to be a direct parent. So no, it doesn't work. We would have to call directly onto the parent. Wait a minute. That's because I spelled it wrong. Let's see if this can work. Still no, so I guess we have to use a direct parent to remove the target. And let me rename this because I liked how I named it before. This makes it very clear. Oh, we can also view the solution. They use a const keyword, and they use a query selector. Oh wow, look at that. Look at the difference between that. you can use a query selector and select it by the ID, but also you can use the getElement by ID method. Wow, look at that. Wait, I've accidentally clicked something. Anyways, so either of these can work. Keep my code, run it, and go to the next step. Interactivity with onclick. Interactivity with onclick. You can add interactivity to DOM elements by assigning a function to run based on an element. Events can include anything from a click to a user mousing over an element. Interactivity with onclick. You can add interactivity to DOM elements by assigning a function to run based on an element. By assigning a function to run based on an element. Events can include anything from a click to a user mousing over an element. Elements can include anything from a click to a user mousing over an element. The onclick property allows you to assign a function to run on a click event on an element. Document.getElement by ID. Okay, so here they captured an element and then they called onclick. And here we are assigning it a function to run a click event on an element. Then our click event is changing the style. Blue button, red button. Okay. To modify the button of the turn button red function so that it modifies the button as follows, assign the dot style background color to red. Okay, so we capture the button and then we use the style method to let us change the property, a background color property, to red. We are also changing the text color to white and also the text to be red button. Now to add interactivity to the button element by adding a function that turns its background color to red and its font color to white. Okay, so what does that mean? So we created this action, this function, and we want this function to happen when this button is on click. So we added an on-clicked response that activates this function. It allows you to assign a function to run a click event on an element. Cool. Traversing the DOM. In the DOM hierarchy, parent and children relationship are defined in relation to the position of the root node. A parent node is the closest connected node to another node in the direction towards the new root. A child node is the closest connected node to another node in the direction away from the root. These relationship follows the nesting structure present in HTML code. Elements nested within one HTML tag are children of that parent element. Each DOM element node has a .parent node and .children property. The property will return a list of the element's children and return null if the element has no children. The first child property will grant access to the first child of that parent element. Access the first child of the body and save it to the variable named first. Okay, so let's look at the index. We want the first child of the body. Where is the first child? Oh, so first child is not a name or ID, but it's an actual property. And that's what they said here. The first child property will grant access to the first child of that parent element. Access the first child of the body and save it to the variable named first. Then, okay, so we did access it. We capture that here. Then we change the inside of it. To access the body of the page, you have to use the document.body. After that, define the variable first and assign it to the first child of the document body. Assign the inner HTML property of first to I am the child. When done correctly, you should see the first header text change to I am the child. The first header text change to I am the child. Okay, so let's see what that does. Alright, so it changes the first child, which is of the body, which is the H1 element. And we change that to say I am the child. And that is exactly what we see. Now we have to use the parent node property to access the parent element of the variable first and modify its inner HTML to I am the parent, and my inner HTML has been replaced. Okay, so to access the parent element of the variable first. Okay, so we access the parent of the first, and then we want to modify the inner HTML, so we call the inner HTML and changed all of that to I am the parent, and my inner HTML has been replaced. Okay, so that means we want to, from here, from the title, from the H1, which is the first element that we captured, the parent of that is the body, so we want to replace everything inside of the body, which is why when we run this, everything is disappeared to that string that we are replacing it to. And finally, for a review, in this lesson you manipulate the web page structure by leveraging the DOM interface in JavaScript. Let's review what we learned. The document keyword grants access to the root of the DOM in JavaScript. The DOM interface allows you to select a specific element with CSS selectors by using the .query selector method. You can also access an element directly by its ID with .get element by ID. Right, and we can also use the query selector on either the ID if we specify it with the pound symbol, or the class if we specify it with the period, or we can specify just an element. And the inner HTML and the .style properties allows you to modify an element by changing its content or style respectively. You can create, append, and remove elements by using the .create element, .append child, and .remove child methods respectively. The onclick property can add interactivity to a DOM element based on a click event. Alright, so the next reading will be, the next section is just a recommended reading, which is on jQuery. Did it say jQuery? JavaScript and jQuery. Alright, so if you want, I can send you the details right here in the chat, and you can buy the book. And thank you for running with me. If you want to look at the videos, you can check out my YouTube channel called Lemon Juice Stand. See y'all next time.